In part 1 of the tutorial creating a starter project in Java and libGDX, we managed to finish 6 steps of the implementation roadmap, including generating the project skeleton, along with creating the texture packing tasks, asset managers, constants, and screen classes. Now in part 2, we finished the project by adding implementation details for the loading screen, the home screen, and the game screen. Once again, this is what our starter project looks like. At first, you see this home screen with a game title and a play button. Clicking this button switches to the game screen where you see a ball flying and bouncing around the screen. You can then click this arrow button to go back to the home screen and the cycle repeats. First of all, let's make some minor adjustment to the ng class. Open the file starterproject.java. In the constructors, let's set the default screen to the loading screen, which is responsible for loading LEM assets using the asset managers. Also, let's dispose on the resources properly to prevent potential memory leak. Now I'm gonna add several getter methods so the core libGDX objects such as sprite batch, camera, viewport, asset managers are accessible to all the screen classes. Now for my own preferences, I'm just going to move the getters to the end of the file because it looks cleaner to me. Once again, the transition of the screen is like this. You start the loading screen to load the game assets. Then transition to the home screen and the game screen. These screens can also transition back and forth between each other. Perfect. Now let's jump to the loading screen. In the constructors, let's set references to the asset manager first. Asset managers equals to game.getAssetManagers, and let's create a few variables for it. Then in the random methods, we're gonna call the assets managers update methods to actually advance the loading process. What it means is that every time you call update, the executing threads blocks for small durations. In this case, it's 50 milliseconds. During this period, the GDX wait for the incoming binary data read from the I/O specified by assets manager. This update method returns when all assets have been loaded completely. In this code, we print out the finished status and instantly change the active screen to the home screen. So if you run the project right now, it'll show you the finished status line instantly. Because our assets is tiny, it just takes a few milliseconds to load them into the memory. What you are seeing here is actually the home screen, which has been already switched from the loading screen. The background color here is incorrect. We want a dark gray color, but it's showing teals. Let's fix that. Open constant.java. The number in the constructor here should have ff at the end to specify the alpha component. In this case, F is 255 or fully opaque color. So this is the list of the main graphics element we're gonna use in our project. A game.title images and a play button with its up and down state images. These are the assets used on the home screen. And a ball graphics and a back button with its up and down states. These are the assets used on the game screen. And finally, a small square region which has the background color of the playing area. For these graphics, you can directly download them from my servers. Here I'll show you how to use the command line curve to download them. Open your terminals or console programs, then enter the command lines curve-O https access.risensoft.com starterprojects.zip, then hit enter. This command will download the zip assets right away into your project folders. Now let's check it. Perfect. Now let's move the zip file to the graphics images folder. Then go to the images folders and unzip the file to extract all the folder. There it is, on the graphics element inside the images folders. You see the game titles, the play button, the back buttons, and so on. These are on the images assets that we are going to use in the home screen and game screen. On the other hand, the files are unused right now, so I'll delete them to clean up the assets before packing them up into a tester alert file. Since we already have all the images assets ready, let's pack them up into an alert file so we can load them into our game using the textures alerts. Navigate to the project root and inside the terminal run the Gradle task, Gradle texture packer. The task will pack all the individual images into one single file game.png inside the assets folder. Now let's check game.png. As you can see, it already contains all the graphics element inside the graphic images folder. So instead of loading multiple individual sprites, now you just need to load a single texture file in the entire life cycle of the game. Now we got everything we need to implement our home screen class. To begin with, let's make some references to the game stage, the sprite batch, and the status atlas object. The first one is the state object, which is the central object to build our game user interface using Scene 2D. Then the sprite batch, which is responsible for rendering the backgrounds and other game entities. For our home screens, there is no game entities, so we only use the sprite batch to draw the background. Later on, when we implement this GameScreen, sprite batch will be used to render the bouncing ball. And finally, we need the texture atlas, which has been loaded with the asset managers during the loading screen state. Here we get the asset manager instance from the entity class first, then call the methods asset managers get game.atlas to obtain the atlas instance. The final parameters of the get method specifies the type of the loaded assets, in this case is texture atlas class. With the atlas, we can easily obtain the background of PNG texture regions using the file regions method. Now take a look at the home screen again. The starter project title here is a scene to the images. We need to calculate its dimensions and save them in the two variables title width and title height. Similarly, the button is a scene to the image buttons, and we need to figure out its button width and button height values too. Ideally, we want the dimensions to be proportional to the screen size, so as the screen changes, the title also scales up and down based on the screen dimensions. Back to coding, let's create a game title image instance. Game title is equal to new image. Let's take the game title texture region as the input parameters using texture atlas. Now we calculate the title width values. Let's get the current screen width using the viewport. Then multiply it by 0.9, so the title width is shorter than the screen width bit. Then we can calculate title height based on title width values and its original aspect ratios. We take the title width, multiplying with the game title original height divided by the game title original width. Now let's set the image dimensions using the set size methods. Game title, set size, title width, title height, really straightforward. Additionally, let's set the image origin to be in the center. This is important to correctly set the image position later. Alright, for the buttons, we'll use the image button widget, which needs two instances of texture regions for its up and down states. Since we have packed on the graphical assets before, now we can simply get the texture region directly with the texture atlas. First, the texture region drawable for the up state. Then the texture region drawable for the down state of the button. Again, the graphics for the update states had the names play button.png and the down states had the name play button.png. Now let's calculate the button ratios. The play button get width divided by play button get height. Then we set the button width to be less than half of the title width. And calculate the play button height using the width and the original button ratio. Play button height equals to play button width divided by play button ratio. Now because the image button is a table-based component, we have to get the image cell first, then we can set its dimension using the cell width and height methods. Finally, to make the button respond to the click event, let's add a listener to the button. To use the click listener, you can simply override the click methods inside the anonymous class. Once the player clicks the button, let's go to the game screen by calling the setGameScreen method. Alright, now we are done with setting up our scene to the components. Let's render them to the screen. First off, let's apply the game viewport settings before rendering anything. Remember that we currently have two active viewports. One is the feed viewport for drawing the game entities, and the other is the scene to the viewport. And because we want to render the game entities under the scene 2D component, so we apply the game viewport first. Now call set projection matrix for the current cameras. This simply calculates the correct projection matrix using the currently applied viewport and camera settings. Then we can begin drawing with try batch. Let's group on drawing commands inside batch begin and batch end methods. For the home screens, we have no other entities except the background, so let's draw the background with the dimension that match the viewport width and viewport height. Once we are done with the background, we can start rendering our scene 2D components. Again, let's apply the screen viewport of the stage. Because the stage manages its own sprite batch, we only need to call stage act and stage draw methods to process user input and draw the stage child components. If you run the code right now, nothing shows up because we haven't actually added any scene 2D actors to the stage yet. Let's jump right into the show method to add our actors. To begin, let's remove all the existing components so we have a clean stage to work with. Now add the game title actors by calling stage add actors game title. Then let's clear the game title action so there is no ongoing animation left on the actor. Now we have to calculate the position of the game titles. Let's set the variable graphics height to be the current screen height. Use the game title set position method to specify the position of the actor. For the x coordinate, let's center this on the screen. Let's take the screen width minus the title width and divide the result by half. For the y coordinate, we also place it in the middle, but also lessen minor offsets so it stays on the upper part of the screen. Now the game title has an initial scale of nearly 0 because we want to create an animation that scales up the actors from 0 to its normal size. This kind of animations can be easily generated using action static methods. Game title add action method to add the new actions. Then we want to add a small delay before the animation starts. Call actions delay to generate a delay actions. Don't wait for too long, just 0.25 seconds is enough. Lastly, apply the scale to action to scale the actor up from nearly 0 to 1 within 1.25 seconds and use the swing out interpolations. Alright, let's test our new code. As you can see, we just create a scaling up animations with just a few lines of code using libGDX into the API. Let's go ahead and add the play button as well. The process is very similar to adding the title actor. Stage add actors play button. We're gonna clean up all the button actions first, then set up its positions on the screen. Just like before, we want to center the button on the horizontal axis. Using the same formula just like before, Gdx graphics get width minus the button width and divide everything by 2. But for the vertical axis, we want to push it down a little bit. This makes extra room and spaces between the titles and the button. Simply take the middle screen position of the game titles and minus the button height. Also, let's set the button opacity to 0 first, because we want to fade the button in when the animation begins. Observe that the animation also repeats infinitely, because the button keeps floating up and down around its center position. We can do that using a couple of actions that control the timeline and life cycle of the animations. First off, let's use a moveY variable to specify the moving range of the button. Then let's fade the button in, play button add actions, and let's delay it for 0.75 seconds. Then fade the button in within 0.35 seconds. Actions fade in 0.35. At the same time, let's add another action to repeat the animation. Play button add actions. We want a looping animation, so let's use actions forever to repeat any kind of action infinitely. Inside the forever methods, we apply a sequence of actions that move the actor up and down within a small duration. Now to move the actor relatively to its current positions, we can use the move by actions that takes a few parameters. The first parameter is the x-coordinate. Because the button only moves vertically, we set it to 0. Then for the vertical and second parameters, let's use our moveY variable. Then the duration of the animations, and finally the interpolation type of the animation. To make it move down, the parameters are exactly the same, except that we use negative moveY for the second parameter. Let's fix this error by adding the matching parentheses. Now let's run and test our code, and it's working really nice. Again, using scene2D actions, you can create quite a complex animation with just a few lines of code. One minor adjustment I want to make is the viewport dimensions. Suppose we want to develop our game for mobile devices with just a vertical screen. Edit constant.java and change the values of viewport width and height to 9 and 12. Let's change the clear color as well so we can easily see the background region. Run and test the code, and it should be perfect now. So far, we have finished the implementation of the home screen. Right now, when you click on the play button, it jumps to the game screen, which is just a blank screen at the moment. Let's implement the GameScreen class to finish our project. Inside the constructors, we store references of the texture atlas, stripe badge, and stage instances just like the home screen. Firstly, get the textures atlas instance using asset managers, get game.atlas, and use the class textures atlas. Then get the stripe badge instance to draw the background in the ball entities. Finally, get the stage instance to build a user interface using scene2D API. From the textures atlas, we can obtain a texture region instance for the ball graphics and the background textures region, again very similar to the home screen. Now create the ball texture regions with atlas, find regions, ball. Then find the background texture region as well and save with a PG text. Now let's add our rendering code as well. And it's the same process, just exactly like what you have done in the home screen. Which means you apply the game viewport first, draw the background, then apply the scene to the viewport and render the actors to the screen. Batch, begin to start batching our drawing commands. Don't forget to add batch end as well. Then draw the background texture regions at the 0, 0 origins with the dimensions match the viewport width and height. Once we're done with the entities and backgrounds, let's render scene to the actors. Again, apply the scene to the viewport first, then stage act and stage draw, same step exactly like the home screen. Because it's just the same code, I'm going to fast forward a little bit. Here's the interesting part, let's add the back button to the stage so we can return to the home screen from the game screen. In the constructors, let's add a buildUI method. This method contains the code to construct our scene2D layouts and its children. If you want to learn more about scene2D and how to build user interface with scene2D APIs, check out these articles on my website. Inside the buildUI methods, let's make a root table first. You can call the setViewParents methods and setRoot to make the root table expand the home screen. Then call the method rootTop so any newly added actors are placed on top of the screen by default. Now let's create our button. We need a screen width variable to store the current screen width first. Then we can assign the values of the button size to be a fraction of the screen width. This will make the button dimensions responsive and adaptive to the screen size. Now let's create a new image button for the back button, very similar to the play button we did earlier. You need two texture region drawable instances for the up state and the down state of the button. So we can obtain the two regions named back button and back button down from the textures atlas to create our buttons. Now we can change the button size to get the image cell first, then use the cell width and height methods to adjust the button size based on the button size variable we have created earlier. Now let's add our button to the root table using the same dimensions we have calculated for the button. Additionally, let's add some padding around the top edge and right edge so there will be extra spaces around the button. Remember to never use magic numbers for the outer dimensions. Instead, you should calculate the dimensions based on the screen width and height so it can be responsive and adaptive as the screen changes. Alright, the final step is to add a click listener to the button, so when the player clicks it, the screen changes to the home screen. Add a anonymous click listener class, override the click methods, then call setHomeScreen inside the methods handler. To actually show the buttons, we have to add it to the stage as well. Let's do that by going to the show methods, stage clear, and then stage as actor for the root table. Now you can run the code. The home screen shows up. Click the play button to switch to the game screen. Now you can click the back button to go back to the home screen again. The project is nearly finished. The final piece of the puzzle is the bouncing ball class. Let's edit GameScreen.java and add an inner ball class. The ball class is a game entity that has some common spatial properties such as position, x, y, direction, dx, dy, and a local rotational angle. In the ball constructors, let's set the ball position to be at the stage center first. The math is pretty simple here. X equals to half of the world width, then E equals to half of the world height. Then call the reset method to initialize a random direction for the ball. Because the x and the y can be perceived as two components of a normalized directional vectors, we can take any random values for the x and the y between -1 and 1. This is one of a simple and fast way to pick a random directions, but you can use other methods too. Now in the update methods, let's rotate balls by increasing the angle variable. Then let's update the ball positions based on the currently assigned direction, dx and dy. For the ball speed, you can pick any values. Here I'm just using 8 for demonstration. Once the ball touches any of the left, right, or top and bottom edges, we invert dx dy so the ball bounces back to the other directions. Again, this is a relatively simple mechanics for demonstrations. For other cases, you may want to implement your own algorithm to implement a more realistic animation. Now we are ready to render and animate the ball. Go to the constructors and initialize an instance of the ball. Then jump to renders, call update on the ball, and draw it to the screen using sprite batch raw. First off, let's update the ball positions and the angle first. Call balls update and pass in the delta time. The first parameters of draw is the ball texture regions. In this case, is the bgtext variables we declared in the constructors. The second and third parameters are the ball positions. We -1 because we want to offset the ball to the center positions, and because the ball has desired too. By the way, the ball size can be any random values. We just pick 2 just for our convenience. The next parameters are the sprite origins, the sprite dimensions, and the sprite scales. Finally, the last parameter is the local angle of the ball sprite. Naturally, we put the ball angle properties here. This is a small mistake here. The statement should be wrapped inside the batch begin and batch end methods. Let's put them in the correct location. Now let's call ball reset in the show method to reset the ball directions every time the game screen shows up. Finally, you can test the game. The home screen first, click play button, then the game screen with the bouncing balls. That works beautifully. Again, you can click the back button and play button to switch back and forth between the two screens. So, we have just finished the development of our starter project. It's pretty basic and there are no major features yet. Nonetheless, it contains all the essential components that a typical libGDX game should have. Once you have mastered the basics, building your games on top of the foundational knowledge is really straightforward. Now, one more thing is that you can quickly generate just a starter project easily using this tool Gdx-Bootstrap that I create. Check out this video to learn more about using Gdx-Bootstrap to create a starter project for you. That's it for today. I hope you enjoyed the tutorials. See you next time.